What annual rate of interest, compounded 12 times per year, is needed to grow an initial deposit of $1,000 to $1,200 in 7 years? The equation that is used in this particular setting is A is equal to P multiplied by 1 plus R over N raised to the NT power. Now that particular equation has a bunch of different variables in it, and the first one is P, and P is known as the principal, and in this particular case the principal is $1,000. That's what's given right here. That's what you're starting with. Now the value A over here is the final value, and in our particular setting the final value is $1,200. The next value in that equation is the rate, R, and that turns out to be what we are looking for, is the rate of interest that's necessary. The next one is N, and the N is the number of times that this will be compounded per year. So in our case, N is equal to 12 because it is compounded monthly, 12 times per year. The last variable out here is T, and T stands for time. And in our case, the time we're allowing this increase from 1,000 to 1,200 to happen is 7 years. So T is equal to 7. Now I could put all of those numbers in here and solve this equation, but sometimes it's a little bit neater if you just leave those as letters rather than writing out the associated values for those numbers and do the algebra necessary to solve for R, which is the rate of interest, and then once you get that rate of interest, then plug in the numbers. So that's the way we're going to proceed. First thing to do to solve this equation is to divide both sides of the equation by P. When you divide the left-hand side by P, you get A over P. When you divide the right-hand side by P, you get 1 plus R over N to the NT power. Now, at this point, what we're looking for is the rate, but we want to get rid of this power here. Think of this power for a minute. If this were the power 2, in other words, this quantity here was squared, we would take the square root of both sides. If this power here happened to be 3, which is this thing raised to the third power, then we would raise both sides of this equation to the 1/3 power. So from that line of reasoning, what we want to do is we want to take both sides of this equation, the left-hand side and the right-hand side, and raise them to the 1 over NT power. When you raise the left-hand side to the 1 over NT power, you get this quantity right here. When you raise the right-hand side to the 1 over NT power, you're just left with 1 plus R over N. The next step in solving this equation, remember we're trying to isolate R by itself, is to subtract 1 from both sides. When you subtract 1 from the left-hand side of the equation, you get A over P raised to the 1 over NT power minus 1. That is the left-hand side. And when you subtract 1 from the right-hand side, you get R over N. Finally, the very last step, we're trying to isolate R, is to multiply both sides of this equation by N. When we do so, we'll get R all by itself. So when we multiply the right-hand side of the equation by N, you just get R. And when you multiply this side of the equation by N, you get N multiplied by A over P to the 1 over NT power minus 1. And we have now solved for the rate R. At this point, all we need to do is plug in these numbers, and we'll have the rate necessary. We'll start at the far left. R is equal to N, and N is equal to 12, multiplied by A over P. A is 1,200. P is 1,000. That will get raised to the 1 over NT power, so that's going to be 1 over 12 times 7 minus 1. Let's do some calculations here to make this easier. 12 is being multiplied. 1,200 divided by 1,000 is the same as 6/5. And that's being raised to the 1. 12 times 7 is 84. So the 1/84th power minus 1, and that will give us the rate necessary to grow the money from $1,000 to $1,200 in 7 years. Now at this point you have to get a calculator to work through this, but when you put this into a calculator it will come back with 0.026 for your value of R, and the way we usually see that advertised is that is a 2.6% rate of interest will grow the $1,000 to $1,200 in 7 years if it is compounded 12 times a year. So this could be put into a certificate of deposit, and if the interest paid every month was 2.6%, it would grow to $1,200.